Welcome to this explainer. Today, we're diving into some incredibly cool AI news. We're looking at a groundbreaking framework put together by researchers Anka Marjanayan and Adrian Groza. What they've done is build a system that essentially forces medical AI to explicitly defend its diagnoses. It's a real game changer, so let's just jump right in. Look, before we get completely lost in the tech stack, I want you to ask yourself a serious question. Would you be comfortable trusting a critical diagnosis, like say something involving your eyesight, to an AI that just spits out a final number without actually explaining its work? In high-stakes medical fields, a simple, hey, I'm 95% sure, just doesn't cut it if you literally have no idea how it got there.
Here is our agenda for this explainer. 1. The medical black box problem. 2. Enter the Toulmin model. 3. Deconstructing the diagnostic pipeline. 4. Powered by specialized AI. And 5. Human-in-the-loop assessment.
Okay, starting off with Section 1. The medical black box problem. Correlation versus reasoning. So standard explainable AI, or XAI as we call it, often just highlights a bunch of pixels to show you what influenced a prediction. But honestly, highlighting a cluster of pixels only shows correlation. It doesn't tell a story. True medical diagnosis requires explicit justification that doctors can actually audit and verify. We absolutely have to separate mere correlation from actual, rigorous, logical reasoning. Which brings us to Section 2. Enter the Toulmin model, a framework for argument. To fix this whole black box issue, the researchers went old school. They adopted the Toulmin model, which is a classic framework for structuring arguments. Let's break this down using a simple sports bet. First up, you have your claim. This is the conclusion you want people to believe. So for example, your claim might be that the Ravens are going to win the Super Bowl. But, you can't just make a huge claim out of nowhere. You need grounds. This is the hard evidence supporting your claim. Going back to our football analogy, your grounds would be pointing out that, hey, the Ravens have the best defense in the league right now. It's the raw data. Next up is the warrant. This is essentially the logical bridge connecting your grounds directly to your claim. It's the underlying reasoning that authorizes that leap. So, in our example, the warrant is the generally accepted logic that the team with the best defense usually ends up winning the championship. Finally, any robust argument absolutely needs a rebuttal. You have to play devil's advocate to find the exceptions. In sports, a rebuttal might be pointing out the high risk of defensive injuries this late in the season. In medicine, as we'll see in a second, it's about actively hunting for counter-evidence. Moving right along to Section 3, deconstructing the diagnostic pipeline, applying Toulmin to retinal diagnosis. Now let's map that exact theoretical structure seamlessly onto a real-world, high-stakes retinal diagnosis pipeline. Think of it kind of like an elite investigative team handing off tasks. Step 1. A machine learning model extracts visual biomarkers from retinal images. Those are your grounds. Step 2. An agent applies medical knowledge to verify the logic. That's your clinical warrant. Step 3 calculates a certainty qualifier. And Step 4 runs a similarity check to hunt down any counter-evidence, which serves as your rebuttal. Let's look at the actual engines running this whole thing in Section 4. Powered by specialized AI, the tech stack behind the argument. The crucial takeaway here, and this is super important, is that this pipeline relies on highly specialized, distinct AI components, rather than one massive, fragile black box. Data extraction is completely separated from reasoning. We use targeted biomarker extractors for the grounds. For the warrant, we use a Google MedGemma agent that's been specifically trained for medical comprehension to verify the clinical logic. And for the rebuttal, the system employs MedSiglip to actively surface any contradictory visual evidence. Now, we got to talk about confidence. Crucially, this system does not just blindly guess its confidence level. The qualifier is not a learned parameter. No way. It is a strict mathematical calculation derived directly from tracking the quantitative performance metrics of both the extraction and the reasoning models. It's grounded in actual, measurable performance, not just a vibe. For any developers tuning in who are looking to implement this, here are your key takeaways. First, yes, the framework is model agnostic, but you absolutely must meticulously validate your replacement models before swapping them in. Second, build robust monitoring to log per component accuracy. Third, curate datasets with atypical cases to calibrate your MedSiglip similarity thresholds. Otherwise, you're going to get flooded with false conflicts. And finally, do not blindly transfer this. You literally cannot just apply a retinal pipeline to, say, dermatology without retraining the whole shebang. All right, this brings us to our final section, Section 5. Human-in-the-loop assessment. empowering the clinician.
All of this rapid, automated processing slows down and culminates right at the human expert's review interface. By separating the reasoning steps, this design acts as a massive safety net. If the AI misses a biomarker, the warrant agent flags the disconnect. If the rebuttal finds counter-evidence, the human reviewer sees exactly where the logic fails. It makes the failure modes totally visible, instead of just handing a doctor a flawed, aggregated score and asking them to trust it blindly.
As we wrap up this explainer, I want to leave you with a bit of a provocative thought to chew on. If we can force AI to systematically defend its medical diagnosis, literally breaking down every single logical step for a human to review, how might structured argumentation transform other high-stakes industries? Think about finance, law, or autonomous driving. This massive shift from passive predictions to active, defendable AI arguments could absolutely revolutionize trust and accountability far beyond the doctor's office. Thanks for joining me on this deep dive, and I will see you in the next explainer.